then the gender will change. But that's also the root core of these artificial intelligence, because statistically, it is more likely that he's an engineer and she's a nurse, and that's what it's all about. It's statistics, and that's also something you really need to bear in mind. At the reason why these work is because there are bias in the model, so it can discriminate, and that's what it uses to do the optimization. So you need to be aware of that. But all this artificial intelligence and machine learning and deep learning and generative intelligence, in the raw sense, there's really underlying different models behind these. So you cannot just say that it's artificial intelligence, because you need to get the right model or the right network to solve the problem. And typically we would do some categorization within supervised learning. This is where you train an algorithm from a result. So if it's an image of a cat, then you give it 1,000 images of a cat and say this is a cat. And then the same with the dogs. You'll give them the result, just like a kid. If we're working with unsupervised learning, then we are trying more of a clustering technology. So this can also be used to find foreign objects in food production. So how can you look at things that are not necessarily, it's something that is outside the norm, or if you can, between two genders, male and female, can you define so that just only by looking at the data? The last part is reinforcement learning. This is what we know from Google Go or from playing some of the board games, that you can define the environment and then you can train an agent. And if it wins the game, then it will earn a reward. And if it loses, it will not get the reward. And then you can more and more train these agents to be more effective. And of course, that this isn't, there's also something called semi-supervised learning. So it's all grayscale, but that's the classical basic of machine learning and artificial intelligence. What you really should be keeping in mind when you're working with this, that is still back to basic statistics. So you need to think about the data collection, because looking at the domain of data and the bias that you can get in the data collection, that will have an effect on the model. So if you have bias or something that is not generic enough in the data collection, then that is also a problem that would arise in the model at the end. So please have really good instinct about how the data collection is, and make sure that you get a lot of data and a lot of variation in that data collection. Then, of course, it's more about exploring the data, train model, evaluate the model, and then push it into the production environment. So if you're not in the machinery of the AI model and the training, then there's two focused. You should really make sure that the data collection is good, and also maintain and monitor. It's quite easy to make a model that works, but you really need to make sure that it also works tomorrow. And the last point down here, I cannot tell you enough how that is true, because the real world changed. So if the ground data that you've been training on, if that change, the world change. I work a lot with biology, like pigs. Later there will be an image of dead pigs, I will promise you that. But then you can start to see that there will be a change in the underlying data structure in the model, so you need to retrain them. And you'll retrain them typically daily, or if it's in a food production, then you can perhaps do it depending on the variation in that data, but you need to make sure that you consider that of monitoring the model. And when we are looking into the data structure we are typically talking about how we can use it to support and optimize and automate some of the decision throughout the value chain. And that's also something that you need to consider, that if you don't measure it, you cannot not improve it. So getting some good key indication of the production, and I have some examples soon, where we can look into what we've been looking for and looking at. Typically, I look more of where's the problem, and then we can talk about, which technology should we actually use? So should we use some ultrasonic image? Should we use X-rays? Or should we use some of the vision technology that is quite cheap? Should we use infrared? So for me, I don't care that much about the technology. It's more about focus on what the problem is and how we can find a technology that can solve that problem. Some example from the real world. And this is from the slaughtering industry. And it's actually because they are quite open with some of the data. So we also have other industries, but they are actually not that keen of sharing all of the data. But in the slaughtering industry, they are actually really keen on having all of the data visualized. This is from the slaughterhouse, where we also did a digital representation of that using a digital twin. So what we will see in the future is that the physical and the virtual world will fit together. So here you can get image analysis within that and have it in a real world setting. So you can here point on a pig in the virtual world, and then you can get information and use image analysis to classify some of those and mark them if there's an error on some of that. Should it be processed? Should it not be processed? Where should it go? We also do this with other things like bread and pancakes. This is a GODP project that we've been looking into reducing waste in the baking industry. And this is something that we've worked for the last couple of times, where we have a vision system set up where we can look at pancakes and classify them regarding to the quality after the press. And then we can gain OE on that equipment and how it actually functions. But typically, I don't know that much about flour and yeast and stuff like that. So this is cooperation in the institute also with my good colleagues in Aarhus, who knows a lot about how we can use optimization based on flour and the ingredients. So here we are combining the quality and the insurance of the flour and the ingredients and trying to see the effect on the end product. So it's more that we're at the institute are able to go out to have both the chemical ingredients information and having the visual quality inspection at the end. The last thing that we actually looked at is that we typically tend on focusing on the product. But here we're actually looking at a lot of the material used in the slaughtering industry, also in the baking industry, where we are looking at what is actually used as a transport medium, because this will fail in the industry. Because this should not be going into the next machine. And it's not the machine fault. It's actually because that the gamble here is not put on correctly. So how can we make alarms on that? And this is also from our automation point of view quite important, because some of these we are actually more or less able to do some adaptive control and to do reinforcement learning to try to control these because there will be variation within the biology. And instead of having that as a problem, then consider, can we then use that for optimization? And this is what we're trying to do here at the artificial, where we did some cutting and also some, let me just see why this isn't running. Oh, it's crashed. Let me just continue then. Then we're trying to use that in the robot to see if we can, from that optimization, use information from the biology to optimize the production. Let me try again. Yeah, so here you can see. So both cutting, but also moving materials within the industry. And in the future, this is an area that has been quite focused on. And we can also see that the way that you interface with robots will change, because you don't need to be able to ROS program a robot, but you can talk to it. You can talk to the robot and say, can you throw the plastic away? And if it needs sorting, then do it. So the way that you integrate with the technology will change. And that's an important thing, because we don't necessarily think about that change, and that will also change the work requirement in the future. And for me, working a lot with food, then we also need to consider that typically with meat, that before it becomes meat, then it needs to have a life. So a big part of some of the projects that we've been working on with Aarhus University is looking at pigs and how they actually have it in welfare, and if they have been standing and lying. And this is also a part of the food production. And the reason why, for me, it's quite fun to work with is actually more because it's so difficult, because it's not just in a line. So there's some random things with these creatures that really make it difficult. Looking at the raw material, so here it could be also salmons, fish. Then we're trying to use X-ray technologies together with breeding companies, so that we are able to quantify the different characteristics of the salmon based on the meat, fat, and bone. We can do vertical cutting and then do that to optimize with the technology. So the fight is on between man and machine, but in generally, as Margrethe Vestager told, it's not that technology is not good or bad, but it's how we use it, how we can implement these technologies in the future to make it more sustainable. So in what we are looking at is actually a food production where we can benefit. We can assist the personnel at the floor to make decision. We can use these technology to do diagnostics. So in the future, it's more working with the AI than changing it. But some of the big things and the difficult part is talking about change, because we as a human society is not actually up for change. We don't like change. So what we have also learned from some of the gaming industry within this is perhaps some of you know Duolingo, the app where you can learn new language. And today at 11, it popped up in my Spanish class, and then it told me if I should use the next way of doing the Spanish word. And then it actually tried to learn when I want to have these notifications for optimizing my effort into the app. So it will actually use AI, deep learning, into getting to know my patterns, if it's a workday or weekend, to learning in how it can be motivation. So also that's in the future, we can see that the workforce will change. We have these generations X and boomers that are coming, and they are much more into the technology. They know how to use it. And this is really important that we think about how the generation will accept this technology in the future. And a lot of things within these artificial intelligence also make it so that you can actually add more value to some of the product. So it doesn't have to cost that much, but you can actually gain a lot of value. And if we look at some of the new trends within the technology, what strike me mostly is more or less the speed. So if you look at the revolution within the technology, is that it took typically 100 years to get these steps. But what will happen within the next 10, 20 years? That, for me, is really something that has been striking. And I think that's all for me. If there's no question or...
Thank you very much, Dennis. Very interesting and exciting to see how the AI is influencing our life and the food processing industry. Are there any questions for anyone? That was clear. Then I think we should move on to Henrik, that has a real life case also. Henrik Ottesen is owner and concept developer from Food We Made. And Henrik will share his experience by implementing AI and machine learning to optimize the food processing within the bakery industry. So the floor is yours, Henrik.
Thank you. You can hear me, everyone, and also
Yes.
see the presentation?
Yes.
Perfect. Well, first of all, thank you for inviting me. It's nice to get a chance to get out of the production and make the other guys do all the work. So, it's a half an hour break for me. How much time do I have, Sandra? Is it 15 minutes or more?
More. You have 15, 20 minutes.
Okay.
So you can just...
Great.
Yeah.
Yeah, and of course, if any one of you have any questions, please let me know. You just shout out, and we'll take it as we go. Well, Food We Made is, I don't know if you know the company, probably not, but Food We Made is a startup company. We collect bread waste from industrial bakeries and from retail stores. The bread that isn't sold today, we collect tomorrow, or the bread that is overproduced, we collect tomorrow. We bring it back to our production, we sort it, and then break it down into breadcrumbs, and run it through a large tunnel oven. And when it gets out the other end, it's breadcrumbs as you know it, dried breadcrumbs as you know it from the retail stores, and you use for when you fry your fish or chicken nuggets or whatever. Yeah. So we know the product, and this is what we do. We don't produce end products ourselves. We produce an ingredient product and sell it as breadcrumbs that can be used for further food production. So we are an ingredient producer, and you might say, well, why don't selling Føtex, Bilka, Schulstad, whomever, why don't they do this themselves? Because this is not a new idea. We've been doing this for many years, using surplus bread back home in our kitchen, and using it when we do different kind of dishes or bake new bread or whatever. This is also true. There's nothing new in reusing bread. The problem is when you do it at a large scale, it becomes very difficult to handle it and get it into an efficient flow in your production. Because if you look at Schulstad, for example, they produce 70 million tons per year. So it's quite a lot, and if you have 1 or 2% of waste, that's a lot each day. And if you need to have a guy manually sorting and depackaging and so on. This is very resource demanding, and it's difficult to make efficient. And you could say, just to give you an idea as to how much waste there is, one Bilka store has just around 1 ton of waste per week. So it becomes quite a lot that you need to handle, you need to collect, and you need to sort, you need to depackage, and so on. So this is, of course, a challenge. Another challenge is that if you would actually choose to do this manually, then you can't just put all the bread into one big pile and then shred it and bake it into a new bread, because the food regulations state that you need to know exactly what ingredients you put into your bread. So when you declare the ingredients, you have to do it in a decreasing order. So the ingredient with the highest percentage has to be on top, and then you move down the list. So if you don't know which breads you mix together, then it's very difficult, not to say impossible, to make the right decoration. Also, of course, you need to declare the ingredients as well. This is another challenge, and of course also the allergenic problems. So there's a lot of challenges that makes it difficult to do this efficiently. And then, of course, there's the documentation on ESG, CO2, carbon footprint, and so on and so forth. This is also very difficult to do if you don't know exactly what you put into which fractions and which kind of breads goes where. So this is a challenge that we are trying to use or to solve using AI. And the way we do this is that when we receive the bread, we and as I should of course state that we are still developing the solution. So this is not, so if you call me tomorrow and say I want to come see what you're doing, then you're not going to be able to see that much. But we've designed the system and we're working on developing it now. So we've done a lot of testing and so on. It's just a disclaimer, so you know this. But anyway, the idea is that when we receive the bread, we put it on a conveyor, and then it moves single file under a camera using visual recognition technology. You know this from your phone. This is the same technology that recognizes your face, more or less. Then the camera takes a picture and compares this to a large picture database and says that, well, this particular picture of this bread looks most like the 200 other pictures I've got of a specific bun or a specific bread, rye bread, whatever type of bread. And based on this comparison, it concludes that, well, this bread has to be this specific type. Then the sorting station says that, well, when you move further down the conveyor, when you get to station 5, this is where you need to get off. And then when it moves down the conveyor, station 5 knows when this bread comes, I need to push it aside. So this is pretty much the way we're doing this. So we are building a picture database of all the different types of bread. We're training the algorithm just like Dennis described a few minutes ago. So the more pictures we put into our algorithm, the higher precision we're getting. And also, as Dennis said, that if we change just a little bit, then we have to retrain or rebuild the picture database. Otherwise, we get an inefficient sorting. So This way, we are able to take around 4,000 tons. This is the goal, to take 4,000 tons of bread each year. That's, yeah, you can do the calculations, about 12 tons a day. We run through the system and we sort it into unique specific categories. So we have, we can actually go down and sort into, so that each bread gets its own category. We can also say that, well, we want to combine 3 different types of rye bread into one specific fraction, because this is, we need this specific recipe in order to produce a specific product and send this to a specific customer. Then we can do that. So we can design the different fractions individually, depending on the product we want to get in the end. Furthermore, when we get a new bread, a new product, and we introduce this into our database, then we also get a data package that says, well, this type of bread contains these ingredients and then these nutrients. So when we sort the bread into a fraction, then we know, well, if there's 100 breads of this type, 50 breads of this type, 20 breads of this type in a specific fraction, we can also automatically calculate what is the combined ingredient list and what is the combined nutrient list based on this is simple mathematics. Based on the percentage of each bread, where you can calculate what is the share of ingredients from each bread type in this specific fraction, and then you auto-generate an ingredient and nutrient list. So this is one of the ways that we can do this much faster than you would be able to do if you did it manually. Furthermore, it increases the safety, because this is more efficient than if you were to do it manually and you had different guys doing this. You would get probably different results each day depending on which guys are doing the sorting. So using the AI, you get a more consistent output. Yeah, so this is it, and of course also another plus is that doing this we are able to do. I totally forgot to move forward in my presentation. Anyway, of course the traceability as another plus in this system. We are able to trace the specific bread all the way through our system. When we collect the bread, the first thing we do, we send out bags to the individual stores, and they sort the bread into the bags, and they put a QR code on each bag, so that we are able to scan this QR code, and we know exactly where does this bread come from. So the first thing we do when we receive a bag is that we scan the QR code, and we know that in this specific fraction there will be bread from this store, this store, this store, this store, and this store. So we've got a very high level of traceability on each end batch that we produce. So this is another advantage from using the AI and automation technology. And of course, yeah, we can do this at a much higher efficiency than when you do it manually. And of course at a much lower cost also. So this is of course a key issue, because the only way to make this concept viable is if you are able to do it at a large scale. So if you only move 100 tons a year, then you shouldn't do this. You need to go way above and produce more than 2,000 tons a year, and you cannot do that if you do it manually. So you have to introduce AI and automation. So this is one way to do it. So this is and you might think, well, what do you do with the bread that's wrapped? Well, we are currently also designing a de-wrapping machine. So most of the bread we get today is not wrapped. That is fresh bread from the bakery sale in Føtex and Bilka. So this is, of course, a little bit easier for us to handle because we don't need to depack it. Also, we don't need to worry about the bread going bad because it's only day-old bread. So it's it can when we receive it, it could actually stay at us for a week or so without going bad, but we process it the same day or within 2 days at most. So we don't have any problems with the products going bad. But as soon as we move into the packaged bread, this becomes an issue because this is usually on the shelves until the last sale by date, and there's a bigger chance that we get bread that is with mold or that's the primary issue. And the way we want to address this is that we are looking at different ways to introduce a scanning device that can sniff. I don't know if you know the NIR technology. So we can do infrared scanning of the bread, and this is able to not only detect mold, but could also detect if there's any plastic residue or anything else that foreign bodies that is not sorted out properly. So this is another well, it's I don't know if you would call it AI, but it's anyway, it's no less, it's automation that is used to do this efficiently. Let's just see. Right now we've I'll move to this one. We've done testing of the solution, and it's a simple test we've done. We've done this with the Alexandra Institute, and this has been done both on packaged bread and depackaged bread. The results are the same, using a simple algorithm that hasn't been trained at all. Just taking 10 pictures of each bread type, you can get around 95% efficiency on the sorting algorithm. So of course, if you train it even further, you would get an even higher efficiency in the sorting. So you can get around, I would say, a 98% efficiency in the sorting of the bread. So this is quite efficient, and of course, if there's any mistakes, it would just go down, or if there's anything it cannot recognize, it just goes down in a waste fraction. So it's an efficient system, and it's a good way to combat this challenge and make an efficient system. And we've also done a little bit of testing in our own setup, and this is what we are trying to build on now. We've designed how the entire sorting line should look, and we are pretty much ready to build this. However, we are we've chosen to spend a little time trying to test our business model before taking on a huge investment in automation equipment, because if we can, it's nice to know that the business model is viable, because there's no reason to have a nice sorting equipment that costs several million if there's no one that wants to buy our end product. So right now we are doing a lot of stuff manually, producing end products in order to test if there's anyone that wants to buy the products, and there is. So we are moving forward now and scaling up our production, and also working further towards doing the automatic sorting line, or producing the automatic sorting line. The design we have right now, we are also looking at. We actually think we can do it a little bit smarter than we have, and than the initial design we've done. So we're also looking at different ways to do this than we initially and then how we initially thought we would do it. So it might not look like we expected it to when we are done, but hopefully it's going to be the most efficient solution that we are going to choose in the end. Yeah, I think this is pretty much what I wanted to share with you. I don't know if you have any questions for what we're doing, or.
Thank you very much, Henrik. I have a question. You of course have some challenges during this process. What is the main challenge you have experienced when you look at this AI and during the phase?
Well, yeah, this is a good question. Actually, it's perhaps a little bit specific, but the bottom of the bread is typically what looks the most similar. So if we are only looking down at the bread from the top, then it's not a problem. If the bread moves under the recognition or under the camera with the top up, because if you know this, when you get into the baker store, you can look at all the breads and you can visually see a difference between each bread. But if you imagine that the baker would turn all the breads so it turns upside down, then it would become more difficult to distinguish which bread is what type. And this is the same for the camera. So we've been looking at different solutions if we should do a 360-degree scanner, or if we should do it just from the top. If this is enough, even though if it comes bottom up, can we still recognize the bread? So this has been a very specific challenge. Also, yeah. Sorry. Just I got disturbed there. Yeah, also choosing the right way to. But again, this is a little bit more an automation issue. When it moves down the conveyor, what is the most efficient way to move it out of the conveyor? Is it pushing it off the conveyor, or is it blowing it off the conveyor, or should we do it another way? So this is more an automation issue. Actually, the recognition part, the AI part, has been the easiest part of our production. So it's I think it was the Alexander Institute guys that said that, well, if you can see the difference looking at it yourself, then you can be sure that the camera can determine the difference as well, or the algorithm can determine the difference as well. So, and we've got quite an easy product to work with, because I can't remember any bread that looks exactly alike. So most breads you would be able to see a difference. If I know the same system has been used to look at the difference between newborn chickens or chicklets, and I think that would be a bigger challenge, a way bigger challenge. And if it can do that, then it definitely won't be a challenge for it to distinguish between two pieces of bread. And this has also been our experience up until now, that it's not a problem. It's just keep training, building as large database as possible. Then you will get the efficiency you need.
Thank you.
Yeah.
Someone else that have some questions? No? Dennis, I thought about the same to you. What is the primary challenge you are seeing in the AI in the food production? Are you also saying it's the most easy part is the AI, or what do you think?
It's the AI model is, as long as that it's not just getting the data, that's quite easy, but it's getting the variation. So you need to make sure that you gather a lot of variation in that data, because train the model, that's typically 5-10% of that. Then you need all of the data cleansing. And then you need also to consider that when you put this into a production environment, then if you have small biases in that model, that it will scale. So small problems in the training will actually can cause real problem in the production environment. So you need to take that into account and monitor your models. But it's not, because that we can think about, that we can consider. It's always the human factor, how we actually can gain the benefit from this. How will we react? What should they do? So for me, it's much more how we can communicate the data to the staff, to the people. Should we do some diagnostic using AI, or how can we actually benefit from this? Because just doing a classical deep learning model and doing that classification or segmentation, well, that doesn't benefit the company. So how can you actually think the cost benefit through, and what are the consequences of your analysis? So you need also to think that what would you use the information for? Typically, what we always try to do is that you do some samples now. So you take 100 pieces or 50 pieces of your bread product or of your meat product and do a sample. Then why not think about considering having that real time? So instead of having samples of 50 pieces an hour, then have 98% of that sample analyzed. And you won't be able to do all of it, because typically then you have 2% that flips upside down or something. But it's way better than what you have at the moment. And that flexibility and that make you able to perhaps change your process early on, and that can benefit the company. But for me, it's always the human. The data and the machine I can handle, I can do the modeling, we can do all that. But it's, for me, it's having the commitment from the company and stating, I can give you this data, but what will you do? And making sure that the commitment from the company is on. Because all of the other thing is, for me, quite trivial, and it's quite fun. But talking to people instead of have the real intelligence, not the artificial. It's the real intelligence that, for me, is the difficult part, but also the fun part.
We need to adjust so we can use it the right way.
Yeah.
Thank you very much. Yeah. Again, anyone? Any questions? then I think we should give them a virtual hand. And thank you very much, Dennis and Henrik, for the great presentations. And I will wish you all a great day and weekend when you have that. So yeah, look forward to see you in the real world. And yeah, have a nice day.
Yeah,
Bye.
you too, guys.
Yeah.
Bye.
Goodbye.
Bye bye.